Hello and welcome back. Topic for today is measure of spread and the learning goal. So by the time you finish the homework and practicing with spreadsheets, I can calculate a measure of spread for a given set of data. So let's begin. So recall, we just finished talking about measures of central tendency, so mean, median, mode. And they're an indicator of the central values of the set of data. So it tells us, the on average or the midpoint, this is how we would represent our data. So today we're looking at measures of spread. Okay? So measures of spread use those values, mean, median, and mode, in some form or another. And what they're doing is these are quantities. Let's circle what I want to highlight here. So measures of spread, these are quantities that indicate how closely a set of data clusters around the center. So we are going to be analyzing sets of data using mean, median, and mode, and we're going to determine how good the data is. So similar to our measures of central tendency, where we had three, mean, median, mode, there are also several measures for spread. So we're going to be looking at standard deviation and variance, quartiles, interquartile range, percentiles, and z-scores. All right. So the first one we're looking at is standard deviation and variance. So a deviation is the difference or distance of an individual value from your set of data and the calculated mean for the data. So what does that mean? So if x is a data point, so whatever, 40, 45, 70, your variance or deviation, so variance will be x minus mu, if we're talking about population, or x minus x bar. So there's our variance from the central data. So some formula here on how you calculate deviations. So when we're looking at a population, again, this is if you're getting data from Stats Canada or the entire school, for example, we use sigma notation. Okay, so it's a Greek letter, and sigma simply indicates that we're dealing with population data. And the equation that associates with deviation here, or standard deviation, it's the sum of x minus mu squared. So it's the sum of the variances squared over capital N. Now you're starting, or will start appreciating the fact that we are using a spreadsheet. In the good old days, we didn't have that luxury back when I was a youngster. So, and if it's a sample size, standard deviation we use with an S, and the formula for it is very, very similar. It's the sum of the variations, but now it's measured from our mean, which is taken from a sample size over n minus 1. All right, so there is your formula. So sigma and S is your standard deviation. So we're getting some terminology and formulas out of the way. You do want to put this formula on your cheat sheet for future reference. X is the data point. Mu and x bar are our means. So we're going to have to calculate mean in order to do this. N and small n are your population sizes. Population or sample sizes. All right. So there we are. Now population variance is the mean average of the squares of the deviations. So what exactly does that mean? Well, quite simply put, is you take your standard deviation, so the formula, the two formulas we just talked about, and you simply square it. So we're looking at sigma squared. So what does that do? It just eliminates the square root sign. So it's just the same formula as above, manipulated a little bit, and it just calculates something else, and we refer to it as population variance. So the same variables, so I don't have to create a new legend for you. It's the exact same terms that are in it. The formula just has, instead of a square root, a square. So those are the formulas. Now, for the most part, unless otherwise stated, so a little bit later on, we're probably going to be using this early on, our formula for a sample size. All right, we'll get into the large populations a little later on. All right. So the example, determine the standard deviation for the height of people in data management. So again, we have spreadsheets. All right, so we want to find the standard deviation. So what that means is, using that formula, if I go back, standard deviation, I'm going to have to find the mean height of everyone. I need to know how many people are in the class. I have to find the sum of the differences, and so on and so forth. So a couple things we have to do first. And like I said, we're going to use a spreadsheet to do this. So I'm going to refer back and forth. So once you've entered it into your spreadsheet, what we can find is, and I'll just write it down here once my computer catches up with me, mean. So at mean, so I want the mean of the heights. Bracket. So there we go, 173.5714. Going back to the formula, what am I going to use that for? So I need to take every data point and subtract it from the mean and square it. Okay, so x minus x bar. So we might do this in stages the first time, and you can take shortcuts later on. So x minus mean. So that means I need to take equals this value, my x value, minus the mean. All right. Now, keep in mind that mean is always the same number, so we need to use our dollar symbol to make sure it remains the same. And there's our mean, or sorry, our x minus our mean. So we'll copy that formula, and we'll paste it all the way down. So we have part of what's inside the brackets. We have what's inside the brackets, x minus x bar. Next, I need to square it. So I go back to Quattro Pro, and it'll be x minus mean squared. So the symbol with the formula to do a square, you need to use the caret in order to use a square here. So we're just going to simply take this column and we are going to square it. So there we go. So we copy that all the way down and paste it. And there is the x minus mean squared from our formula. So x minus mean squared. Now we need to take the sum of it. So you can see it builds. So if you have the formula sheet, you work your way in, or work your way out. So we want the sum. Okay, so I'm just going to go down here. Sum of bracket x minus mean squared. And you can write this up however you want. Okay, so at sum, I want the sum of this column.
Would Logan Newbrand and Rick Otten please come to the office? Logan Newbrand and Rick Otten to the office, please.
So now I have the sum. So I have everything on the numerator here. Okay. Now I need the denominator. I need to know how many items there are and subtract 1. So I need to know how many people are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 people in the class. So what I will do now is standard deviation. So SD on here is equal to, now to do a square root, I'm going to put everything inside the brackets. I'm going to take the numerator divided by, I'll need another bracket because I have to do this minus 1. Now, and you can do the point, or you can do the 13 without having to worry about that. And to do a square root, I always take it to the exponent 0.5. So there we go. Standard deviation for this class is 17.9. And here is that process on how to do it. So I'm just going to do a quick capture here. So I bring this forward to my note. Moving to the note, moving it so that it's on one page, bring it, oops, went the wrong way here, put it in this example here. So here we go. All right, so let's go back to full page view, back to the note. Okay, so This is what this chart would be. In the old days when we did it out by hand, you would take this chart and you'd simply extend it out. And you're always welcome to do this by hand, but look how many calculations you have to do. So now this chart here from the spreadsheet is our replacement. Okay, all the calculations are done for us in there, and it's just a matter of keeping track. And this is what we were looking for right here. Okay, standard deviation of 17.9. All right, Sermon standard deviation for the people in the class. All right.
Nicholas McCollum to the office, please. Nicholas McCollum to the office.
And now, when I look at the second part of this question here, so that's all there is to the first one. Standard deviation is simply that calculation. So just one more time, the standard deviation, S, was equal to the square root of the 4171.4 divided
Logan
by...
Newbrand, please come to the office. Logan Newbrand to the office, please.
Divided by the 13, and that's how we got the 17.9. All right, so standard deviation, it's measuring the distance from our central mean for our data. So to compare it with another class, if we found out Ms. Caldwell's class had a standard deviation of 10.5 and the average height was 180, what conclusion could we make? Well, first of all, our class is shorter on average because our median was 173, so that's 173 centimeters versus the 180. So definitely the other class on average is taller, and we have a wider range of height compared to the other class. And that comes from...
Nicholas McCollum to the office, please. Nicholas McCollum.
That comes from the standard deviation. All right, so our standard deviation, okay, comparing that in brackets, that is 17.9 centimeters versus 10.5. So just remember what the standard deviation, if we go back for a couple slides here, okay, the standard deviation, it's the calculated mean, okay, for how far away our data is from that central point. Okay, so we're measuring, okay, how closely our data clusters around the center. So when we look at that example comparing the two classes, okay, Ms. Caldwell's class of 10.5 centimeters means that the height of the people in that class are more uniform or closer to being the 180, whereas ours, we have almost an 18 centimeter variance when we're comparing it to our class average. All right, so that takes care of deviation and variance in this part.